Hello folks. Beside me here we have a Model 3 drive unit. I believe this is from a Model 3 and it is a front drive unit, so it should have the induction motor as opposed to the permanent magnet unit that we see on the rear. Now, you might be saying, well, that's great, Damien, what are we going to do with it? Well, my head's completely melted from doing work on the Model 3 inverter PCB project. So I decided that the best way to relieve that particular stress from myself is to instead do some mechanical work on this, which is kind of a spare Model 3 drive unit that I have here. So as you will see, this unit is missing its inverter. That's because I took the inverter off this to send to Arthur, who is helping me with the PCB project. Now I do have an inverter that can go back with this, but that's not what we're worried about at the minute. What I'm most interested in is this area here and what's behind, let's call this door number 2. Now door number 1 here is the actual motor, is kind of the direct motor shaft. It's a coupler that sits on there. But this guy here sits in the middle, kind of between the motor and the differential. And there's a very good video by Professor Kelly at Weber State University that shows all of how these gears work. So if you're interested in that and in a proper description rather than my monkeying, then go watch that. But I'm interested in what's going on here behind this, and hopefully if any of this nonsense idea that I have works out, we'll be able to do something rather interesting. Now, that said, I'm going to go ahead and zip out some fasteners here, and hopefully we'll be able to get this case to come apart. Alright, so step 1 anyway is I've got to take this oil cooler off because 2 of the fasteners are in here behind that. I think that's good enough. That's an E12 for those of you playing along at home. That's out. I think one of them's already been pre-removed for me. Going with my trusty sandwich bags here for keeping these fasteners together. Oh yeah, that's pretty forward. There we go. Just a couple O-rings and so on. Okay. I'm going to start zipping out, these are I think E12s again, yeah, so I'm going to start zipping these out. I'm not going to bore you. Okay, I think I have all the fasteners out, and that means of course I don't. Got some rags, my snap-on dead blow hammer and custom pry bar set is missing. So instead I'm going to use a lump hammer and a blunt wood chisel for this particular task. So in theory we should be able to separate the gearbox halves, I believe. Yeah, the poo is flowing. Let's get the anti-poo devices in here now. Oh my god, it's like a lake. Elon, no! What are you doing? Don't do it, Elon. Some kind of amateur hour. Yeah, we're going to need another pry bar. I'll put the part number in the description. This is a Tesla service tool. Oh. Okay, there is stuff happening in here, so that's good, I believe. Of course, now we have to be very careful that we don't mar any of these mating surfaces, folks, but that's why we use the proper tooling here, as you can see. If we put that service tool in that way, yeah, and then I take the original service tool I am not a gome, Damien. You're the gome, said Elon. Service tools needed. Ooh, this is another service tool secretly obtained from a disgruntled Tesla employee. Right, now, oh my God. Come on, Elon. Come on, buddy. Stop giving me a hard time here, will you? Some kind of thing is caught up here. Some kind of oil pipe. Oh, hello, Elon. Hello, Damien, he said. Okay, wow. Alright, folks, I think we can scratch what I said at the beginning of this video. This is most definitely not oh yeah, that's permanent magnet motor. And it also has some kind of new Musk tech here in the shape of these hairpins. So this is some kind of, somehow I have ended up with a kind of, I don't know, newfangled Musk motor. It's got these newfangled bar thingies here rather than wire. So that's interesting. Now what's most interesting for me, one of the primary reasons for cracking this thing open, is to figure out the oil pathway in here. So let's see if we can figure that out here. It looks as if this is our oil pump. So it sucks in here. There's a metal strainer in there. Delivers it up here into the oil filter. And it comes out of the middle of the oil filter. And then comes over here into this pipe. Does this come out? Not yet. So it comes up through this pipe and is discharged here, which then goes in here into our oil cooler. We then come out of the oil cooler through that guy here. We then go in, you won't be able to see this for a minute, but I'll bring you in a sec. It's over here on our thing. It goes into that bearing thing I was showing you at the beginning of the video. Probably, does it go up the middle of that rotor? It does not, that I can tell. I want to get something and see if I can stick it into that. Hang on. I missed something, folks. We come out of the oil cooler, but this pipe has a Y in it here, and it goes back into the motor. So I'd say this is cooling the stator, and this is indeed hollow. So I'm guessing we're sending some oil in through this pipe here, going to the stator. Then we send some up the pipe here through the middle of the rotor. And all that's going to spill out in the back and come back out either through this bearing. It'll lubricate this bearing. It's got this discharge area here. It can't come out through these because these have plasticky things that go in there. But it presumably then comes back out here and back out through this bearing and basically splash lubes the rest of the gearbox. That's my theory. Probably wrong, but that's what I've got at the minute. Alrighty, so the area of most interest to me here now is this guy here, this middle shaft. This is our motor shaft here. This is our lay shaft, I guess you could call it. And this one here is our differential. So now let's see if we can removing some of these here. You know, this one wants to come up, but does this one want to come up? This is, I guess, going to be the tricky one, isn't it? That's going to be, there's another bearing down there, so that's going to be stuffed into it, like another one of these big bearings down here. So, oh, totally not. Yeah, it's coming, all right. I think it's coming. You coming out, Elon, buddy? Come on, Elon. Don't be such a gome. guess the next thing to try and do is to start edging this guy out, but damned if I know how to achieve that. So I guess we'll just keep beating on it until something lets go. That sounds like a reasonable plan. Yes. Go on, Elon, stop being such a gome. Progress. All right, we got this one out by baiting on it, and this one came out by lifting on it. So that's exactly what we want. This is our little splashy thing with an integrated oil pipe. That one we very much want. Put the splashy oil pipe thing over here. And finally now, I can release that clamp from here. I want to get this guy out, which is our motor, our friend of the family here, that we want to get him out. So I don't know how this is going to work, probably very badly. Don't see any split rings or anything like that in there. I'm sure this is the approved way of doing it. Yeah, this looks approved. I'm sure the bearing will be fine. Oh yeah, there we go, come on. Come on, Elon. Come on, buddy. That's Zooks, Elon. Yeah, I don't think Professor Kelly would like that. No, I think he'd be a bit hacked off with me. I'd probably fail. Hey! That is some professional grade work there, folks. Okay, that is our one that goes on there like that. Okay. So recall, from what we can tell here anyway, the oil gets sent in two ways once it comes out of the cooler. It gets sent back here into the motor stator. So that's our stator feed. And I guess it'll lubricate part of this bearing and part of this bearing. Ah! My studio lights. Stop it, damn you. There we go. Now, then gets sent in here. So it gets sent through this gallery here, which pops it into the middle of this guy. And we have a little plasticky thing here that presumably sends the oil, yeah, there it goes, back up through the rotor. And then we have another one here. What's going on here? Oh yeah, we have another little, okay, so then looks like there's some oil can come into this bearing somehow here. Now that's not terribly a problem for us. Not terribly a problem for us. Okay, we're back with our modifications. So since we last saw you, which was only a few seconds ago for you, but it's been several weeks for me, I've pressed off the two bearings from our intermediate shaft, also pressed off the big gear. So, turns out these bearings with their weird numbering system, which of course made in China, are actually just good old that's not it. Are actually good old 6308s. So I got myself a 6308 here. That's going to replace the bearing that goes, let's call this on the outer side here. You know, 3D printed this little part to center a punch here for me in our portal, let's call that. So I'm going to get a punch this, and then we can drill a pilot hole through the case. So let's see how that looks. Yeah, I got I really won't be able to see it on camera, but yeah, I've got a center dot on there. Let's get ourselves a small drill bit. Make the first incision. This drill bit looks completely burnt out, therefore it's perfect for this task. Really? Okay. Yep. Only the finest precision machinery here, folks. There we go. Yes. Ping. Perfecto. I've washed this out with some brake clean, and we can see here how our oil passages work. Alrighty. So, in our casing, we've JB welded this guy, and I've JB welded the little cross passage in here. You can't really see it too well, but once I get the tape out and that in a day or two, I should be able to see that. And that'll block up that oil drain and that cross passage there for us. I know, high quality. Now, on to the next part. Right, so this is our intermediate shaft, I guess you could call it. We've pressed off this gear. We need to keep this guy because that meshes with our motor output shaft. And then obviously with our two bearings, one of these will be going back on, other one will be replaced with the 2RS. Now, this part here, this gear that's machined onto this, would normally have been meshing with the differential gear like this, and then transferring power outwards to our half shafts. Now we're eliminating the differential, so we won't need any of that. But what I want to do is I want you to see something here, and it's just worth noting that when this is meshed, I'm going to say there's two gears that are fully meshed and then one coming in. So it's kind of like there's kind of like two always meshed. So I want you to keep that in mind. Now, what we're going to do is we're going to be performing a special procedure with precision engineering equipment on this part of the gear here. So stand by. Now the big question. Yes. Bingo. We have soft metal. Let's party, Bennett. Oh, Bennett. Ooh, look at that. Let's party, Bennett. Now you might be thinking, why didn't I break through all the way here? Well, the problem is that this is most likely case hardened steel. So what we've done here on the top is we've ground away the hard bit, and that lets us into the nice soft steel here in the middle that we can actually drill through. well, with a conventional drill press anyway, and just a conventional high-speed steel bit. Now, the reason we stopped drilling there then was that we've now hit the hardened bit inside, so that will require some further investigation. Yes, I don't foresee any problems with this plan, any downsides. Go me thing. Oh, yes. Ah, really? I'm trying to film a high click rate video here, you gum nut of a thing. I need clicks urgently. I need some kind of disaster to befall me. Oh, I'm gonna think something happened. There's no more teeth left on the drill bit. Let's turn off that and turn that off. So, yeah, there's definitely no more teeth left on the bit. But to my absolute amazement, we have successfully drilled our way in a 16mm saw right the way through this friggin' thing, folks. Okay, things have moved along a bit. Here in the vise, we've our Elon part, and here we have our BMW part. So I had a local engineering shop turn this down to what I specified as 23mm. Turns out that was a little bit of a broad spectrum, so I had to machine this myself. So what we've got here, this is sitting at broadly between here and here, 22.95 or 22.97, as best as I can measure it, and as best as my 1954 lathe can actually do. The diameter here is 22.90, and you can see it just sort of kind of wants to go, but not really. Now, my first thought with this was doing a full interference fit, or a sweat fit. And to do that, we would have had to heat this guy up with the oxypropane until he was red. We'll probably have this about 0.15, maybe even a little more bigger. Then shove him in, let him cool, and la-di-da, you've got a very good sweat fit between this and this. And if I had attempted to do that, I know the internet would have had a conniption, because obviously this is a hardened, tempered, heat-treated part. Also, it's not everyone that has the facilities to do something like that. So we're not going to go that way. Instead, we're going to do a very, very gentle press fit here. Now, I have a hydraulic press, and with that kind of an interference, I'm pretty sure I could press that in completely cold. We're not going to do that. We're going to warm this up very slightly, folks, so don't get yourselves all worked up. We're using a map torch, which most people will have, and we're looking probably to get this thing up to, you know, maybe 150, 200 C, and at that rate then this guy should just slide in there, theoretically. There's a lot of theory going on here, so less theory, more practice, as you might say. Yep, that's the Damien finger test. Okay, let's see, give that a clean off. Alright, he wants to go. He wants to go. He wants to go. Yes, folks, I had to cheat because I'm a screw up. Did have to use the press. Didn't want to keep banging on this because I just end up mushrooming or damaging that part. What it pressed in actually took a good bit of pressure to put it in there. I haven't pushed it in all the way yet because I'm going to be doing some sizing and so forth. But the next part of the operation will be to put this wheel back on here and then put our bearings on and so forth. Oh no, it's not actually. I tell a complete and utter lie. Next part of the operation, we have to grind the other part of this flat. So I've got to cover up these parts and sand this out again. And then we'll be putting our key in here. Courtesy of trailer towing pin. It'll be going in there and everything will be just perfect. Probably not, but hey, it's great fun. How well you're going to be able to see this, but down there now we have drilled into the BMW gearbox shaft. About 2/3, a little over half, yeah, about 2/3 of the diameter. And the mission now, ooh, that guy's a bit warm. We got a piece of hardened steel tractor towing pin thingy, and I'm going to be driving that into that hole here, and then we are going to weld this in here, and we're going to cap this off and smooth it out. And this is going to be our primary means of preventing the two shafts from turning independently. All right. That's nice and cold anyway. Let's see here. Great bit of fun with that, I have to say, drilling into it, but we got there. A tiny taper on the end of that too, so it should kind of sit in there pretty well. So what I'm going to do now is I'm going to start welding this, but I'm going to weld it very slowly. I'm just going to do opposites and let everything cool. Got some welding gloves here just around the bearing surfaces and the other bits that we want to protect. Now, I know that the cool people out there would be all tigging and stuff like this, or they wouldn't be doing any of this anyway. They'd have everything probably cutting splines and all kinds of things, but we are going to be using for our project today, we're going to be using some of these guys. These are known, I guess, more commonly as 29-9 welding electrodes. They're generally used for dissimilar metals and things like that, so I don't know if you'll be able to see that. High strength problem solving alloy for all steels. Well, I don't know about you folks, but I nearly always have problems, and this will hopefully solve some of them. Okay, so we're running 80 amps, it's a 3.25 rod, and we're on DC electrode positive. Let's see how badly I can screw this up. Yeah, pretty badly. Okay. Can't be that easy. No. Can't be that easy. No. I never get away that easy with things. There we go. Feast your eyes on that beauty, folks. Look at that. Professionalism. No. All right, so next up we have the end here, and this guy here is about 25 mil. The BMW shaft is about, that's only hand warm. BMW shaft is about 25 mil back from the end of the Tesla one. So what we're going to do next is we're going to go in there and do a few spots around this part here. I'm not going to, go ahead and fill this whole thing up. We're only going to get a little bit of a tacks in here really, because obviously I need to be conscious that this is one of the bearing surfaces here. Yes, we can. There's one more over there now I want to get, and then we'll call that good. You can see it's kind of boiling off those drops of water there now. Because I had tape going around that or not, but anyway, weld inspection time. So there's some horrible boogers in there, as they like to say, but they'll do something. And sanded that guy down there for our little pin key fellow. Now, as tempting as it would be to weld in here, I'm not going to be doing that. And the reason being is that this would then create a fracture point on our BMW part of our equation here, so we're not going to do that. Folks, here we are. All back together. So it took a bit longer than planned because my Chinese hydraulic press committed seppuku during the process of putting the gear back onto the kind of main part. First of all, the frame went from being a rectangle to a rugby ball shape, and when I fixed that, the bottle jack let go, so then I had to replace that with my own proper bottle jack. But good news is we are now back together as well as can be. We've a standard Tesla bearing here on the back, just one of their own open style ones, and as we discussed previously, on the front then we have a 6308 2RS C3 bearing, which is a sealed version here on the front. So let us see if we can pop that back into the rear case housing thingy. Alright, so obviously this is going to be the part that gives Professor Kelly some indigestion. So let's see. Pop that guy off there for a minute, and let's see how dreadfully I can film this. This guy, yeah, Professor Kelly's definitely not going to like this bit. Come on, Elon. Not gonna clown, Elon, will you? I only deal with smart people. Okay, got to get serious here now. Look at that. Dial D for Damien. Not. Alright, let's see how this one goes. Uh-oh. Moron. Moron features. I got you this time, said Musk. Damn you, Elon, with your superior intellect. The Musk got me, folks, with his superior intellect. Elon, no! Yeah, I got you with my superior intellect. Well, it looked great for a while, didn't it? I mean, to be fair, the Musk intellect, of course, beat me. I should have known. Let's lump hammer that back out. Now, almost all the way back out. Careful, of course, to avoid any potential damage. Ah, beautiful. Now we got. Oh. Look at you. Look at you, you mad man. You mad man, you. Of course, what I could do is just cut out all the part where I was beating on it like mad in order to make myself look better. Yeah, must actually do that. Uh-oh. Yeah, it's the old motor. Aha! Oh, baby! Yes! Look at that, folks. Look at that. Is that not a thing of true beauty? Okay, folks, our mission for today, should we choose to accept it, is to see if we can get this nightmare back together again. Now, there's a couple of things we need to do before we dive straight into that. First is plugging up Elon's unused orifices, or orifi in this case. These being the half shaft and bearing locations where the differential would have been. So for that, I've 3D printed these little bungs. Bit of carbon fibre, not carbon fibre nylon, carbon fibre polycarbonate. It's the most high temperature material that I have. And I've gone ahead and put one in here on this part of the casing. And this little sticky bit here basically then comes out and seals on using the original half shaft seal. And as well as that, just to be on the safe side, I put a little skim of gasket cement in there. So I'm going to go ahead now and we'll fit this guy in here into the into, I guess, the motor side, you might say. So in order to achieve that goal, what we are going to do is, I've got some, again, high temperature gasket cement. To get more of this stuff this morning. Oh, it's a little, look, it's even got this little applicator thing. Nice. For that, and yeah, and then we're going to go, oh yeah, we're going to go, like that. Oh, it's grey. Interesting. All right. The old applicator. And we a cutting device to fire up the applicator. We do. Nice one. I might need a little more off that, actually. There we go. All right, applicator. Now, before we apply this stuff, because I don't want to damage the seal in there with our bung, so what I'm going to do is going to put a little touch of this silicone paste that I normally use for brake caliper sliding pins. So it won't hurt the seals. So that'll just let that hopefully pop into that half shaft seal easier. Fingers crossed. And legs and toes and all that. So we'll put a little bit of this, not much to see really. I'm just gonna squeeze a bit out. Hopefully you won't be able to see anything there, so that's brilliant. All hail my superior camera work. Before we do that, actually, I've been just blowing this out with compressed air just to make sure there's no nasties, and whatever nasties that I did have in here, then I made sure that I blew them into the motor where they'll do no harm at all. Don't know if you can see it here, but in this kind of oil tray here, where normally the differential gear would sit, I drilled a hole in the bottom of that because there won't be a gear in here now, and I don't want this to kind of get filled up and keep oil from circulating around, I guess. At least that's my theory anyway. Let's see if oh yes, there's our nice high temperature goo. Seems to be behaving itself. There we go. There we are. High temperature goo is in. Doesn't need much, just to be sure that we get a seal. And then we can hopefully put our plug in here. Plug that musk. Now I need a plug applicator 5000, also known as a mallet. There we go. That is one sufficiently plugged Muskian outlet, I guess. Okay, wish me luck, folks. I think we all know how badly this is going to play out. All right, so pretty much apart from not having the differential in there, this should go back together the same. Obviously this guy will be coming through the hole that we've drilled in our front. Just giving all these O-rings a little shot of silicone spray. Just going to put a little on the bearings as well, just to hopefully mean I don't have to beat the tar out of them again in order to get them on there. Our case half is also blown out. There shouldn't be any debris in there. JB Weld is sanded down, so again I don't think we'll have any problems there. I'll give a little hit of that just for this guy here. And of course I was about to forget to put the gasket in, which would have, knowing me, I'd have had the whole thing, you know, bolted up and torqued to spec, and then I would have forgotten the gasket. So, oh well, right. Yes, professionalism here. Wait now, let's try it now. Hang on. Oh, I can cut this bit out anyway so that I don't look like an idiot. Remind me to cut this bit out, folks. Oh, look, you see there. See, that's it. Gasket fitted in the appropriate manner. Right, so let's put this thing on here and see how terrible this is. Okay. This way, please, Mr. Musk, if you wouldn't mind. Sir. Uh-oh. Elon, what are you doing? Oh, that's what you're doing. Okay. Oh yeah. He's protruding through. He is trying to protrude. Come on, Elon, protrude, buddy. No, he's not protruding. Of course he's not. Elon, you and I are going to have words. Serious words when this is all over. Now, remember, folks, the last thing you want to do is to beat on this when you're putting the electrical connections in, because they're very easily damaged. So, yeah, don't beat on it, because that's really stupid. Yeah, I think it's actually going on. That's crazy. Oh my God. Look at that, folks. I mean, as expected, folks. Yes, everything according to plan. Alrighty, and we've all our fasteners just screwed in on a few threads by hand. We will now proceed to torque them to the correct spec in the correct tightening sequence. We rotate backwards for the angle torque. And then finally, I think there's the upside down triple inversion torque setting, where we flip the drive unit. That's the one there. You see that? There you go. And then we go so that you can learn from them along with me, kind of thing. Now, where's my fastener container 6000? Here we are. There we go, and obviously you can see our seal in here. Alright, oh, that's strangely off center, but I'm sure it'll be fine once we torque it to spec. Appropriate tool. Right, yeah, that one's just fine, so let's do this one instead. That one obviously doesn't need any. There we go, and there you go. Absolutely, yeah, hang on. Oh, I'm the only, I can, really? Oh, sorted. Now, coming up in tomorrow's episode, which you will see in a few seconds, we're going to get to see if my local motor factor can indeed supply us with the correct oil filter. Folks, I know what you're thinking, and in fact I kind of know what you're screaming at the screaming at the screen. You're going to be saying to me, Damien, you're doing it wrong. Just because you used a seal bearing here doesn't mean that it's going to seal back all of that oil that's going to be sloshing around in there. Now, you'd be correct. I am not assuming that at all, which is why we have one of these things, which is an off-the-shelf oil seal that I picked up at my local farm store. Just so happens that he's going to sit on the smooth part, because he's a smooth operator, of our BMW drive shaft here. And yours truly here is going to be testing his FreeCAD skills now in a few minutes. And we're going to design ourselves a little seal holder that we're going to be able to put in here. And we're going to 3D print that guy. And then seal him into the housing. And he'll obviously carry the seal. So when this Musco shaft turns, you'll be running in that oil seal there. You see? Not as... Okay, yes, I am as dumb as I look. Okay, fair enough, okay? But maybe not in this case, okay? Because we have a seal. Alright, so just in case it wasn't obvious, this is our BMW gearbox output shaft. So we'll be able to refit this guy, which is our, I guess, drive shaft flange on there. He'll need to be, I got to clean up these splines, and this will probably need to get hot to slot on there. And then once we have him on there, so you just put our locking nut back on, and then we should theoretically be able to connect a BMW drive shaft to this thing and get it to work in a rear wheel drive application. Okay folks, time for today's exciting edition. So, as you might have already spotted, we've our 3D printed oil seal holder test fitted in here, and seems to be pretty darn good. We have to ready for your operation, Mr. Musk. So we've also picked up, which I hope will be the right one, a oil filter for Mr. Musk. So let's have a look first of all at our oil seal here on the BMW gearbox shaft. So what I've got here is a terrible camera angle. So let's see if we can change that. Oh yeah, no, it's still a terrible camera angle. Let's see if I can improve it some more or make it worse even. Oh yeah, if I could make it worse. Let's see if we can make the camera angle worse. There we go. Now you have a worse camera angle. You can't see anything. Excellent. So this is our 3D printed carbon fiber nylon or not carbon fiber nylon, carbon fiber polycarbonate. And it's got a standard off the shelf oil seal. It's 35mm ID, and I think it's a 50 or a 52mm OD. This little part presses in here and just basically sits in that edge there. Sits against the seal on our sealed bearing. So the mission right now is, we're going to attempt to use some gasket compound in one of these, of course, excellent tech bottles to see if we can fight some of that out, to put a little smear of silicone sealant around here, pop that guy back in. So I won't expose you to my pathetic attempts to make this can work. Yeah, it's crammed up full of goo, of course it is. Yeah, no, that's all gooed out. Brilliant. You really would wonder what kid they had designing this kind of stuff. Probably looks great in Fusion 360 or something, but you know, then when you actually need to get the goo out of the can, it's, oh well, just buy a new can, of course. Silly me. Oh wait, I think I can pump it. And I pump it here like this. Oh, the goo is coming. Okay, we got goo. Right. Managed to release the goo. Release it. Now we do the smearing of the goo. I think there's a drop left in one of these spray cans that I have. Yeah, no, I don't think there is actually, Damien. That's completely empty. Oh, let's just pretend. Whee! There, see? Lots of oil on that one. How about some silicone spray instead? Oh yeah, that'll work. There we go. Sorted. Ah, excellent camera work. Thank you. Right. Now, theoretically, remove the goo bottle. We slot that guy home. There we are. Now, we gotta just smear the goo around Elon's areas here. So basically this is what we're going to be going for, folks. Hope you can see that a little better there now. I think the purpose has been super dull for the last part of the morning, and then the sun comes out just when I need to film something. But this is our BMW gearbox output. This is our flange, and you'll see on the back here there's another spot for another seal which we will be using. Now this guy will go on there. I think there is only one way that goes on, or I might be wrong about that, as if I'm wrong about a lot of things on this job. There we go, there it is. So that'll obviously push on there, and then we'll be able to have our output on that. Now what I'm then going to have is a little bit of aluminium sheet, say 3 or 4mm, go on here and fix into these holes where the inverter would have been. And we'll put another oil seal on the back of this. And that'll help keep any dirt and debris out of this area here where we'll have our HV connections coming out. But that's going to be for the next part of this video, because I suspect, folks, that you've already had quite enough of this project. But So far, I have to say, it is looking pretty good. Now, lastly, just for fun, we'll flip around to the back and see if our wonderful blueprint oil filter fits. Obviously, I have to get a dirty rag and that a bit of a clean. Make sure there's as much dirt as we can find in there. And looks like there's a missing screw out of that oil pump, so that'll be another job for me. So, for those playing along at home, as I said, we have a blueprint ADBP 210139. Not tried this, so no idea whether it's gonna. Oh, blueprint. Come on, Elon, let's go, buddy. Or Elon spare parts department, or non-Elon spare parts department. Really? Seriously? Packaging good. All other things bad. Now, we don't have any oil, so we'll just use silicone spray on that. It'll be perfectly fine. Now, Elon, you going to tread on there? Oh, look at that, folks. Made for the job. It fits. Yay. So there you have it, folks. Part 1 of our Tesla drive unit. Drive shaft modification. Don't forget, as always, to give us a thumbs down. Don't check those links in the description. And suppose until next time, happy Model 3 drive unit drilling.